Welcome to Algebra 3. We're in lesson 46. This is part A, complex roots. So first I'm going to go over a few terms just to refresh our memory of some things and some terminology. The lead coefficient of a quadratic formula or quadratic equation, it is the known factor of the x2 in the quadratic equation. So the known factor, all three of these, you have a 2 and two x's, right? So we don't know the x's. The known factor is 2 because technically this is 2 times x times x. We don't know what these two are, but we do know what this one is. So the known factor of the x2 term in a quadratic equation, that's going to be your lead coefficient. Now that's important to know because that is the one that we're going to use to divide with in the coming problems. That's the one that we have to, we don't want to try to figure out what we need to multiply the lead coefficient by in order to factor. We want to simplify as much as possible. And to do that, we just want to say x times x to get x squared. We don't want to have to deal with another factor. So typically we divide by the lead coefficient every other term in our quadratic equation just to simplify the whole equation so that we can bring it down to smaller numbers, which are easier to then factor to find our roots. That leads me to roots. Roots are what x equals in a quadratic equation. So for instance, if I say the roots are -7 and 4, then what that means is we have factored the quadratic equation into something like this. Now this is not the factors of these. This is just an example. So that means we have factored, and we have two factors here, two binomial terms that are factors, or binomial expressions that become our factors. And what we would do is set each one of them equal to 0, which would then determine our root by subtracting 7 from both sides. Then x would be equal to -7, or adding 4 to both sides, x would be equal to 4. So our roots would then be -7 and 4. So sometimes we're going to be given problems where we are given the roots and we have to go backwards, right? We have to start here and work into here where we figure out what the binomial expression is that is equal to 0 so that we can put it back into our factored form, and then we do distribution and get back to our original quadratic equation. So that's what roots are, just to refresh our memory. I know that you know already, but we're just, making sure we're all on the same page using the same terminology. Now that we've been through that, let's talk about complex roots. Complex roots are just like complex numbers. They're going to have that imaginary factor. So let me clear the page for us. That imaginary factor is going to make it a lot harder to deal with. So let's look at example 46.1 just to kind of wrap our head around what we're going to be dealing with in working with complex roots. So we need to write the quadratic equation with the lead coefficient of 1. So that means we're just going to have x squared. We're only going to have a lead coefficient of 1, so we don't have to deal with it. It's going to make writing this a lot easier. And our roots are going to be 1 plus 2i and 1 minus 2i. What this really is where we have 1 plus or minus 2i. This is just kind of a simplified form of this. This is what we actually end up with when we solve the quadratic equation, but we simplify it when we start with the roots by writing them separately, just in this one problem so that we can wrap our heads around it, okay? So don't worry about that just yet. So what this means is we have x is equal to 1 plus 2i, and x is equal to 1 minus 2i. So now we have to take this whole thing as a factor, right, as a expression, and we're going to put it back in line to the other side. So here, because this 1 is positive, we're going to subtract this from both sides. So we're going to subtract 1 plus 2i and 1 plus 2i from both sides. So this would cancel. So what we have left is x minus 1 plus 2i is equal to 0. Now, because this is a negative, we know it's a negative 1. We have to multiply. So x minus 1 minus 2i is equal to 0. So this would be one of the factors that would be in our quadratic equation. Here, we would do the same thing. Subtract this whole term, or this whole expression, from both sides. This would cancel, so x minus 1 minus 2i is equal to 0. We multiply times that negative 1. X minus 1 plus 2i is equal to 0. This becomes the other factor in our factored quadratic equation. So now we're going to put them back together to write the quadratic equation. So we're going to multiply them times each other. So stacking might be the best way to do that. That's the way that I like. So I'm just going to stack them on top of each other. X, negative 1, negative 2i, and then we have the other one, x, negative 1, positive 2i. Those are our terms, and I am going to start doing our calculation here. So this is going to be negative 4i squared, negative 4, times negative 1 would be a positive 4. All right, this is going to be a negative 2i, and this is going to be a 2xi. All right, now let's move on to negative 1. That would make this a positive 2i, positive 1, and a negative x. So I'm just going to do a negative x over here by itself. Now, x times negative 2i would be a negative 2xi. This would be a negative x, and this would be x squared. So here's what we end up with. This cancels, this cancels. So then we have a positive 5, a negative 2x, and an x squared. And that is our quadratic equation that came from the original two roots that we were given. So that is what we're going to do. That's the process for these problems that we have coming up. They'll tell us what the lead coefficient is, and the lead coefficient is usually the factor that we multiply last. So if we have a lead coefficient of something other than 1, we'll get all the way to the end, and then we'll put that lead coefficient on the end and multiply this, and then that would be our last step. But if our lead coefficient is 1, it doesn't change anything. So x squared minus 2x plus 5, that is going to be our quadratic equation. We just had to go through all of the, undoing of the roots in order to find that. All right, so that's all we have for 46A. Next, we're going to talk about factoring over the complex numbers. So now that we have figured out how to go from the roots with the complex numbers to the quadratic equation, now we're going to figure out how to go from the quadratic equation and factor with the complex numbers.